Alright, so we're going to start with our visual pattern and how do we turn it into an expression. Several different ways, starting first with the table values. So we have our input and our output, or your term number and term value. So term number and term value, again, or input output. You have your first term, your second term, and your third term. So your first term here has how many circles? Has 4. Your second term has 3, 6, 7. And your third term has 10 circles. So what's our pattern? Well, we can definitely say in words that the pattern starts at 4 and increases by 3 each time. Okay, and that's great, but that only helps us if we have to find maybe the fourth or the fifth term, because if it's the fourth or fifth term, no problem, I can just add another 3 and add another 3. But what if I wanted to find the 50th term or the 100th term? I'm not going to continuously add by 3 each time. I'm going to have to use some multiplication and potentially addition or subtraction depending on the pattern. So we need to figure out what does our pattern increase by, and the difference between 7 and 4 is 3. The difference between 10 and 7 is 3. So we know our pattern increases each time by 3. So we can say that 3 times n, right, because a variable, or so the variable, which is the n, and a number side by side with no symbol means multiplication. So 3 times n. This 3 is called our coefficient. Okay, so the 3 is called a coefficient. You might hear the word multiplier as well because it's being multiplied by n, but that's not our whole pattern or our whole expression. So we need to figure out, and I'll see if I can write it in tiny here. If I do 1 times 3, my answer is 3. 2 times 3 is 6, and 3 times 3 is 9. So now you have to think about what's left to happen. So how does 3 become a 4? How does 6 become a 7? And how does 9 become a 10? And when you first start this, depending on the pattern, you might see a couple options, but what should start to happen is the same answer will happen each time. So 3 becomes a 4 when I add 1, 6 becomes a 7 when I add 1, and 9 becomes a 10 when I add 1. So I know that constant, that thing that's happening every single time, is plus 1. So this is our expression, 3n plus 1. And now you should be able to identify all these pieces, whether you're looking at your visual pattern, your table, every single time. So there's one trick with the table that we can do, is if I was to go backwards, and let's say rather than increasing, what if I decreased it and I went to the 0 term? Well, 4 subtract 3 is 1. So that means if I had a 0 position, or a 0 spot in my pattern, there would still be 1 block there, and that's our constant, that 1 that never changes. And then when you get to your visual, you should be able to actually identify or describe which part of that visual is that 1. And this is where each of us might see it a little bit differently, but if we look at this one here, our, I guess, corner of the L, as that 1 block that never changes, it is there every single time. So even if we had a 0 term or a 0 position, that green corner unit would be there no matter what. So then the increase by 3, so the first pattern, I have 2 above the green and 1 to the right. Those, we'll color those in red. Those 3 red ones are still there in the second one, but now I have another group of 3. I've added 2 more to the top and 2 more, or 1 to the bottom on the right. So again, when you get to the third term, the original ones are still there that were added before, and now I'm just adding another group of 3. So again, you have one group of 3. Let's see what I got here. So here you have one group of 3, 2 groups of 3, and 3 groups of 3, which is why we call this our multiplier or a coefficient. Coefficient meaning the number up front being multiplied to this variable. So if I wanted to find when n is 20, so the 20th position in my pattern, I could go 3 times 20 plus 1, and that's 60 plus 1, so 61. So the value of the 20th term is 61.